So I will start what is similarity at the beginning. Well, here similarity concept, we use it many times in our daily life. Like what? Like when I take a photo, for example, with my camera, then your photo will appear on the screen. But of course, your photo will appear it is minimizing than your original one. And of course, the size of the photo is smaller than yours, okay? But it is similar to you, okay? Also, I can, if like in the class, or in the multimedia room, if I put the projector and I put a photo for, not a photo, any picture, any polygon, in order to see it on the board, you will find that my polygon is too small. But when I put it on the projector, it appears big on the whiteboard. That's why it is similar to what I am putting on it, but it is enlarging than it. So maybe the similarity, maybe something small in real, but I want to make it big, or the opposite, something already big like me, and I will take a photo for me. Of course, my photo will not be the actual size. It will be minimized than the actual size. Okay, this is the concept of similarity. First, I have, in this lesson, I have two parts: similarity in polygons and similarity in triangles. I know that the triangle is one of the polygons, but in the similarity, it differs a little bit than similarity of polygons. Okay, the definition of similarity of polygons, or when I say that the two polygons are similar, I must verify two conditions. These two conditions say that the corresponding angles are congruent. It means that the angles in both polygons must be congruent or equal in measure, and the corresponding sides are proportional. Proportional, I will make it clear a little bit what the meaning of proportional now. Okay, but let's go to the first one. Corresponding angles like these two polygons, as you see, polygon ABCD, and XYZL. These two polygons are congruent if the two conditions verified. First, I said the corresponding angles are congruent. Corresponding means the same angle. In angle A here, its corresponding is angle X. Angle B, its corresponding is angle Y. Angle C, angle Z. Angle D, angle Y. So angle A must be equal measure with angle X, and angle B must be equal measure in angle Y. Angle C equal to Z, angle D at last equal to angle L. Is this enough? And if I found two polygons, the four angles, or the five, if it is pentagon or hexagon, it is enough that the angles in one equal the angles in the other. Is it enough to be similar? No, it's not enough. The second condition must be verified also. What is the second condition? The second condition said that the corresponding side must be proportional. Proportional means that when, for example, I will consider that this side is 4, and this side is 2, 5, for example, 3, and 8. Okay, let's make this 10, 6, and 40. This is an example. And these sides are 2, 3, 7, and 5. Okay? What is proportional? Proportional is that when I put one side of the first polygon, divide the second side, the first side in the second polygon, and then I got the ratio between AD, the second side in the first polygon, divide the second side in the second polygon, they must be the same. Let's check. If I put AB, divide XY, these are the corresponding sides. AB supposed to be not to be equal. In this case, in case of sides, not to be equal. I want the ratio. I want to divide them. AB equals 4 and XY equals 2. So 4 divided by 2 equals what? Equals 2. What about if I took the ratio between the second side with the second side of the second polygon. I will take AD with XL. AD was 10. XL is 5. What is 10 divided by 5? It is equal to 2 also. Let's take the third one. If I took DC divide LZ, DC equals 14, divide ZL equals 7, it is equal to 2 also. And the last one, CB divide ZY equals 6 divided by 3 equals also 2. So as you see, AB over XY equals exactly BC over YZ equal CD over ZL equal DA over LX equal constant. For example, in my case here, this constant equals to 2. It is not a must to be 2, but it is a must to give me a constant ratio between the corresponding sides. Okay? Yani, for example, if this one, if I wrote this one 12, so suppose LX to be what? If I know that these two polygons are similar, and the side DA was 12, so who can tell me, suppose that LX to be what? For the same example, if my constant is 2, anyone to tell me?
6.
6, exactly. It will be 6, okay? So the meaning of corresponding sides are proportional means that the ratio between any two sides from the first one over the second one must give me a constant number between all the sides, okay? If these two conditions happen, so the two polygons are similar. How could I write similarity? If I want to write similarity, for example, I say A, B, C, D, similar to X, Y, Z, L. This sign means similar because not in each time I will write similar to, S-I-M-I-L-A-R, no. Similar, this is the sign. Each thing we take or each operation we take along our life, it has a symbol. Like when I say equal, it's not a must to write equal, so I can write it by this sign. Congruent, 3 dashed over each other. Maybe plus or adding, it's plus like this. Subtracting and so on. So the sign of similarity is something like a little bit the approximation, but the approximation was this sign and there's a small dash under it. Here it is only this curve. So when I write this curve, it means similar to. So A, B, C, D, similar to X, Y, Z, L. If this one is given, and he told you that there is a polygon called A, B, C, D, similar to X, Y, Z, L, and I want to ask you, then measure angle A will be equal to which measure? Which one? There is no drawing. I can get it from the writing. The writing must be in order. So A here equal to what here? To X. So measure
X.
A equal to measure X. Excellent. But what about measure B?
Y.
Measure B, excellent, equal to measure Y by the order. Okay, what about measure D?
L.
Measure L. But if I write for you the angle not by letter, if I wrote for you measure angle A, B, C.
X, Y, Z.
X, Y, Z. Okay, طب if I want angle L, Z, Y.
D, C, B.
L, Z, Y. So from here, D, C, B. Okay, also for the sides, I can get it by the letters here. If I want, okay, clear it and write it again, it's easier. A, B, C, D, similar to X, Y, Z, L. Okay, if I want, I will write AB, side AB, proportional to which side?
X, Y.
Yes,
X, Y.
AB, proportional to X, Y. It means that AB over XY must be constant. Okay. Okay. If I write CD, proportion to which
ZL.
side? ZL.
ZL.
Okay. If I say CB,
ZY.
ZY.
excellent, ZY. Okay. If I say AD,
XL.
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 AD, XL. If I told you ZY,
CB.
CB, and so on. Okay, so I can get the proportional sides from the letters given here, not from the drawing. Okay, so I can write the proportional side. So if this is an example, and I will write the proportional side, or as we will see now, that if I want to get one missing from the proportional sides, if طبعا the two polygons are similar. If I want to write the proportional side, very important, very, very important, the order of the letters. So if I say that these two polygons are already similar, so I want to write the proportional sides. So I will start AB over from here XY equals BC over from the other one YZ equals the third one CD over ZL. Then the fourth one is AD over XL equal the constant. So this is the writing of the proportional sides. I couldn't write it something else. If you write AB divide YX, even if they are the same length, it will be wrong. This, suppose if there is an exam, only writing this step, it has 1 mark. Only writing it. Okay, there are some remarks I want to these remarks here, and okay, wait to stop the share of the other one. Okay, here there are some important remarks. The first one, in two similar polygons, if they are called P1 and P2, the constant ratio among the length of the corresponding side, the constant ratio, like the example was 2, this is called the ratio of enlargement or the ratio of the drawing scale. Okay, its name, the ratio of the enlargement or the ratio of the drawing scale or the drawing scale. Okay, if this constant, maybe the constant I said maybe it is equal to 2, like our example, maybe it is half, maybe it is 3 over 2, maybe it is 1 over 5, maybe it is 2 over 5. It can be any ratio. Okay, if this ratio greater than 1, it means that P1 or polygon 1, it is an enlargement to polygon 2. Okay, if it is greater than 1, it means something, it is big, I have it is something small, I have enlarging it. Okay, but if it is less than 1, if the ratio less than 1, like half, for example, if the constant ratio is half, it means that something big, I minimized it. It means that polygon 1 is minimizing than polygon 2. But what about if the ratio, the constant ratio equals 1, equal exactly 1? It means what? That the two polygons are what? Are congruent. The two polygons are congruent. Because if one side is 10 and the other is 10, so 10 divided by 10 equals 1. And 20 divided 20, for example, equal 1. So if the ratio of enlargement or the drawing scale equals to 1, this means that the two polygons, not like these polygons. You will find these polygons will be the same exactly. They will be congruent to each other by everything. This side supposed to be equal to this side. And so on. You will find that they are both the same exactly. So maybe the ratio of enlargement greater than 1, it means that there is an enlargement from polygon 2 to 1, 1 to 2, less than 1 minimizing, and equal to 1, they are congruent. In order that the polygons are similar, the two conditions should be verified, the two, and verifying one of them only is not enough to be similar. This is very important. When you find that, for example, the ratio between the sides, they are constant, you got the ratio half for all the proportional sides, but you found that the angles are not equal in measure, so it is not, they are not similar. The two conditions must be verified. Let's check this one by something it will be very, very clear. If I have two squares, sorry, a square and a rectangle, not two squares. I name A, B, C, D, X, Y, Z, L. Let's verify the two conditions, or let's see what are the properties here. I know that from the properties that the angles are right angles for all of them, right? So it means that angle A with its corresponding, they are equal. Angle B equal to angle Y. Angle Z, D equal to angle L. Angle C equal to angle Z. But are the sides proportional? Are the sides between the square and the rectangle proportional?
No.
Can be طيب يعني can I put numbers and suppose numbers and they will give me a proportional sides?
No.
Of course not.
No.
Why? Because the sides of the square, they are all equal length. And if this one is 5 centimeter, 5, 5, 5. It is a must. It is a property for the square that all sides are equal. Even if I put this sides 10 or 15, okay? So this will be 15. So here 5 divided by 15, it will be 1/3. So the ratio between the two sides, 1/3. But what about this one? Can I write it 15 also? Can I write it 15 to make the ratio constant? No,
No.
because if you write it 15, it becomes a square. It is not a square. So it is impossible to find these two sides equal these two sides in the rectangle. And it is also impossible to find that the four sides not equal in the square. So any square not similar to any rectangle. You cannot find a square and a rectangle similar. That's why I must verify the two conditions. Here, one of the conditions is verified, which is the angles. The corresponding angles are really equal in both polygons. But the sides are not proportional and they will never be proportional. What about if I have a square and a rhombus? Sorry for this rhombus. Okay, suppose it is a rhombus. The properties of the rhombus and the square, that all sides are equal. So I can find that this is 5, and for example, this is 10, and this is 5, all of them 5, and these will be all of them 10. So if I want to get the ratio between the corresponding sides, so it will be DC divided by YZ, for example, 5/10 equal half. All of them will be half. BC divide LZ half. BA divide LX half. AD divide LY half. But what about the angles? I know that the properties of the square, all angles are 90. What about the properties of the rhombus? Are the angles of the rhombus 90?
No.
What is the property? It has a fixed measure?
No.
No, but I know that, yes, each two opposite angles are equal. So angle L equal to angle Y and angle Z equal to angle X. So if this one, for example, 110 and this will be 70, this is 110 and this is 70. So they will never, the rectangle, the square and the rhombus, they will never be similar because I will never see a square, its angles not 90, and I will never see a rhombus, its angle 90. So here I have verified one of the conditions which are the corresponding sides, but the angles will never be equal in measure or congruent. So that's why very important this one, in order the two polygons are similar, I must verify the two conditions, and one of them is not enough. The two congruent polygons, if I have two congruent polygons, they are similar. Okay, they are congruent, so of course they are similar, but it is not necessary that the similar polygons are congruent, because maybe similar polygons, okay, if I'm running out of time after 10 minutes, please go to the meeting again. But it's not necessary that similar polygons are congruent. As we see here, maybe I have one, the ratio of enlargement greater than 1, maybe smaller than 1, maybe equal 1, and when it is equal to 1, so it will be congruent. So congruent polygons are similar, but similar polygons are not congruent. Maybe greater than 1, maybe smaller than 1, maybe equal to 1, and this is one of the cases, this one. If this case happens, they are similar. If not, they are congruent. If not, they will not be congruent. That's why similar polygons can be congruent and cannot be congruent. But congruent polygons are always similar. Or regular polygons of the same number of sides are similar. If you have two pentagons, so they are similar. If you have two hexagons, so they are similar. Regular means what?
I have number of sides, 5 or 6 or 4.
Oh, but the 5 sides are equal. And if they are hexagon, the 6 sides in one of the polygons are equal. Okay, in one of them. And if I have a hexagon, for example, like this one, regular means all the 6 sides are equal. A pentagon, if I have 5 sides, the 5 sides are equal. This is the meaning of regular polygon. So if I have 2 pentagons, regular pentagons, they are similar. If you have 2 regular octagons, so they are similar. If each of 2 polygons is similar to a third polygon, so the 3 will be similar. This is a very easy fact. If I have 2 polygons and you know that they are similar to a third one, so this means that the 3 are similar. And this is, we talked about it, the order of corresponding vertices should be kept in giving names of similar polygons. Like what I have explained, when I want A, B, C, D similar to X, Y, Z, L, you cannot say that angle A is similar to angle Z. You must take the order of the letters of the vertices. Is this clear? Go to the examples and the exercises. Or you want to ask about something? Okay. In the opposite figure, given that the polygon ABCD is similar to the polygon XYZN, it is already given that they are similar. When they are similar, what you will deduce? What you will deduce from similarity? That you have what and what? Okay, I will take the participant here from the beginning. Malak. Yes, Malak. Malak, when the 2 polygons are similar, then you will deduce what? What are the 2 conditions, ya Malak?
المفروض يكونوا
ما قلنا if I want, for example, if I want to prove that 2 polygons are similar, suppose that the 2 conditions must be verified. Suppose that the proportional sides having constant ratio and the angles to be equal. This is if I want to prove that they are similar, but I didn't want this now. I want to get some of the length, but it is given that they are already similar. This is a given, so I don't need to prove it. From this given, it means that what? The angles are what, ya Malak?
Are equal.
Are equal in measure. Suppose that angle A equal to, from the letters here, angle A, suppose it is equal to angle X. And suppose also that angle B equal to angle Y. Angle C equal to angle Z. And at last, angle D equal to angle N. But I don't need any of the angles, but I must know that they are equal in measure. It is a must, because he told me that they are similar. The second thing I will deduce from similarity, the proportional sides. Who back can tell me the proportion? Who can tell me the proportional sides? How can I write them? I want to write the proportional sides. Please don't look at the drawing. Get from here. What over what equal what over what? Very important, this step.
AB. Can I say?
Let's see. Let's take the order, please, of the participants.
ماشي.
Okay, Mariam. They
yes.
are changing. I don't know why. Okay, Mariam. I want to write the proportional sides, Mariam.
Write 4 times 2.
What?
Proportional side of which one?
The two polygons, A, B, C, D, and X, Y, Z, N. What over what equal what over what?
يعني YZ مثلا هتبقى 4 4 times 2.
I don't want any numbers now. I want to write only the proportional sides. What side in the first polygon is proportional in which side in the second one? Like what we have written, ya Mariam, from the previous one, AB over what, ya Mariam? AB will proportional to which one in the second polygon?
NZ 9 DC, sorry.
AB, ya Mariam, AB.
AB XY, sorry.
Look at, okay, don't look at the drawing. Look at here. Get the proportion size from here in order not to be confused, because maybe this one, it is turned upside down. Then this one, you cannot find it from the drawing in this case. Or you can, but it will be difficult. So let's look here. A, B, C, D, similar to X, Y, Z, N. This is a given. I will use it. So AB over what?
XY.
XY equals. Then the second one will be what? AB. We have finished AB. What's next?
DC.
BC over what?
YZ.
YZ. What next?
DC.
Move with order, ya Mariam, please.
Okay, sorry.
You are looking at the drawing. CD over
ZN.
and the last one.
AD.
AD over
XN.
XN. Okay, this step again, it is very, very important. This step is very important. When the two polygons are similar and he's asking about sides, I must put the proportional sides in a correct order. Without this order, the answer will be wrong and you will lose marks even if you wrote this one in a wrong place or a wrong way. So don't look again, don't look at the figure, look at the given. A, B, C, D, similar to X, Y, Z, N. So move with the letters by order. AB equal over XY equals to BC over YZ equal to CD over ZN equal to AD over XN. What next now? I want to substitute what I have given here in their places. He gave me that AB, I will move here. The one which I have its length, I will write it. The one that I don't have its length, I will keep it with letters. So AB, do I have AB? Yes, from here or from here, so it is equal to 6. over, okay, let's write it 6 over xy. Where is xy? Is xy given? No, it is one of the requirement. So I will leave it xy. BC, do you have BC? Yes, I have BC 4 centimeters. YZ, do you have YZ? YZ, no, it's not written in the givens. What about CD? CD given? Yes, it is 9. ZN, yes, ZN given, it is 3. AD, yes, 10 over XN, no, XN not given.